Hello, this is Amanda Cleland, and today we are going to be talking about supply chain management, section 7, materials management and handling. So, materials handling. Let's go over some general definitions to begin with. So, material handling, what this is the movement, the protection, the storage, the control of all materials and products throughout our supply chain. And this follows them through the many different stages that they go through, from manufacturing to warehousing to distribution to consumption and finally disposal. So all of this is encompassed in material handling, the movement, protection, storage, and control of all materials and products. And material handling incorporates a very wide range of manual, semi-automated, and completely automated equipment and systems that actually make our supply chain work very seamlessly. And all aspects of supply chain management, where items are stored, where they're transported or manufactured, are included within materials management and handling. And from a logistics perspective, this encompasses both inbound and outbound activities. So inbound means anything that is coming into us as a company, coming from our suppliers. And outbound activities, anything that is going out from our company, moving towards our consumers, towards our retailers, towards our distributors. And the use of technology to manage these material flows is very widespread. And it includes the use of things like barcodes, RFID, satellite tracking systems, robotics, and a lot of different software and system solutions. So there's a lot of technology that is used to manage these actual material flows in our supply chain. And so we're really talking about the physical products when we talk about materials handling, but not just the physical products need to be handled in supply chain, but also the information. We talked about the 3 different flows in supply chain, information being one of them. Both information and the physical material products are both very important assets that organizations need to manage carefully in their supply chains. And therefore, it is very important that organizations with supply chains obtain adequate return on these assets, on our physical material, and on the information. We've got to get a good ROI on these assets. And materials management, what this does, this allows employees to optimally locate, optimally process, and optimally move items within all the different physical locations, from warehouses, distribution centers, manufacturing and plants, and retail stores. Again, we want to be able to find things when we need them. We want to process them. We want to move them quickly and efficiently. And time spent searching for assets really eats into productivity and profitability. Again, you think of these companies that they know where everything is, but there's a lot of time spent looking for, let's say, lost items. So say one worker, if they spend 10 minutes a day searching for and trying to gather the necessary materials, necessary products they need to do their job, this worker is going to lose the equivalent of one full 40-hour work week per year doing this. So you can see how it really is a huge time waste if we just can't optimally locate things. We can't find them. We can't process them. We can't move them if we don't know where they are. So it's a huge time suck if we don't have a good materials management and handling process in place. So let's review some of the more significant events that have occurred in the development of materials management. And material handling developments have occurred in greater frequency in about the last 25 years, so especially the turn of the century. And this is due to a multitude of reasons. It's due to the advent and introduction of e-commerce in the late 1990s, the use of the internet, and improvements in computer hardware and software. So let's go through some of these very significant events throughout history. So let's go back all the way to 1887. So we developed the first rudimentary hand truck. And you see I've got a picture here of this hand truck. If you've ever moved before, you've probably utilized one of these. If the UPS or FedEx driver has a big package that they have to bring from their truck to your door, they're probably going to be using a hand truck to actually deliver it. So this was the first piece of equipment that was developed to assist workers in the movement of products. Everything before this was essentially you would have to carry it by hand. And the reason why this was invented is because back in the day, during this time period in the late 1800s, there was a lot of young boys that would work on docks, and 10, 11 years old, and they could be very small in size, not incredibly strong, but they were able-bodied and willing to work. Now, they couldn't move these really big sacks of spices on docks. They were just too darn heavy for these young boys. And so someone came up with the idea of, how do we ensure that we can help our workers, these young boys? Again, there were no child labor laws back then, but how do we ensure that we can get them to actually move these things without hurting them? So this is where this was first developed, the first rudimentary hand truck, late 1800s. Now we're going to jump into 1925. So the use of pallets begins here. And for those of you who are unfamiliar with what a pallet is, you see I've got a picture of it here at the bottom. We've got a wooden pallet, and we're going to talk a lot more about pallets in depth later in this section. And what a pallet does, it allows vertical stacking of products. You can see in the upper right-hand corner of the slide here, I've got a picture of boxes stacked vertically on top of one of these pallets. Sometimes you may hear a pallet called a skid. What a pallet or a skid is, it's a very flat transportation structure which supports these goods in a very stable fashion. And usually you're going to use a pallet when you're going to be lifting things by a forklift, something called a pallet jack, a front loader or jacking device, or even some kind of crane. And I've got a picture here of a wooden pallet. Most pallets today are still made of wood, but pallets can be made from a variety of materials. They could be made from plastic, they could be made from metal, paper, even certain types of recycled materials. So there's a lot of different ways, materials that we can use to make our pallets. So this was 1925. In the 1950s, so two-way radios are introduced into warehouse operations. And what happened with these two-way radios is they were outfitted onto forklift trucks so that the forklift driver and who was ever in charge of controlling his movements, telling him where to go through the warehouse, what products to pick up or drop off, he was able to communicate, he or she was able to communicate with each other. So the forklift driver wouldn't have to drive all the way to one end of the warehouse and come all the way back only to find that they had made a mistake. So this really resulted in significant reduction in time and labor. And this was very similar to like a walkie-talkie. It just allowed better communication and a lot less wasted time. 1953, the first counterbalance dock levelers are introduced. So you see here in the upper right-hand corner, I've got a picture of some dock doors. And the thing in blue, kind of beneath that structure that is blue, kind of a bar-like structure that is beneath the white dock door, that is what a dock leveler is. What this does, this enables trucks of varying sizes to be able to load and unload cargo with optimal efficiency. Now, we know that trucks come in a variety of different sizes. The loading dock is not necessarily going to match the height of every single truck out there. And when the dock and the truck's height doesn't exactly match up, there's going to be a gap that's left between the truck and the dock. And again, you're going to have a gap. What if there's something falls in between there? What if someone falls in between there? It makes it very cumbersome and very dangerous to load and unload that truck. And the dock leveler, what that does is this bridges this gap regardless of the truck height. So this was 1953. In the 1960s, robotics are first employed in warehousing. So manufacturers started to utilize robotic arms for handling things like hazardous material or what they called very difficult products. So especially when it was dangerous for a human to handle them, they turned to robotic arms. And the first industrial robotic arm was Unimate. This was invented. And Unimate was capable of moving the materials around about like a 12-foot radius within a manufacturing unit. And you see the picture on the bottom here. This is the Unimate being demonstrated. So you can see what it kind of looks like. It almost looks like something out of a Star Wars movie. And General Motors, GM, was the first to use these robot arms in their manufacturing at one of their New Jersey plants starting in 1962. So we're starting to see robotics being used in warehousing and materials management. In the 1960s, this is when we really started to see automation becoming very widespread in materials handling. Not everything was being done manually by hand. There was a lot of automation first starting to be introduced in the 1960s. So in the 1960s, the first automated USPS, the US Post Office, opens in Rhode Island. United Airlines open a mechanized air terminal in San Francisco, California. And Sara Lee, known for their delicious desserts, they opened the first automatic food warehouse. So again, we're moving from everything being done manually by hand to more automation during the 1960s. And in 1970, the Occupational Safety and Health Act, OSHA, is passed. Now what OSHA is, this is the most significant, most all-encompassing legislation that really impacts worker health and safety, and it became law in the US. And the main goal of OSHA is to ensure that employers provide their employees with a safe environment that's free from hazards, free from exposure to toxic chemicals, free from excessive noise, any mechanical dangers, heat or cold stress, or unsanitary conditions. So this ensured that by law, employers must keep a safe environment for their workers. So this didn't exist before. There was no laws that enforced this. So this was the first in 1970 in the United States. Another thing that happened in the 1970s, in addition to OSHA, was the first high-rise storage facilities are constructed. And I've got a picture here. You can see that these shelves go all the way up to the ceiling of a warehouse. So we can really maximize the storage density. And there were rack heights of up to 100 feet, 100 feet high. Again, previously, before, they did not get this high. They may have gone to what a person could reach, maybe 6-8 feet. So because they had these high-rise storage facilities, they started using equipment like narrow aisle forklift trucks, car and lane systems, and mobile racks to make this really dense storage more accessible. And we're going to talk more about what these types of things are later in this section. In 1970, let's make sure. Okay, I didn't skip anything. 1979, digital displays replace manual listed punch cards for order picking. And remember, order picking is when someone orders something, that warehouse worker or robot has to go into the warehouse and actually pluck that item off the shelf for processing to get to the final consumer. That is picking. And it used to be that pickers had actual paper lists that they would use, or they had certain punch cards. So now it could be much quicker, hands-free. You didn't have all this paperwork lying around. Digital displays allowed picking without all that cumbersome paperwork. So we're moving more into the processes that we are very well acquainted with now. In the 1980s, computer hardware and software started to be used very extensively in warehouses. This is when we started seeing warehouse management system, yard management systems. And this was because there was the personal computer development coupled with a lot of improved software really allowed warehouses to more efficiently and effectively manage operations instead of doing everything by hand. Now we could utilize algorithms through computer programs and make everything work a lot quicker, a lot better, a lot faster. 1999. So this is officially, and I don't know, the 90s wasn't when e-commerce really started, but e-commerce essentially begins in the late 90s. Internet usage had expanded. There were new distribution channels open for many different retailers and manufacturers. Again, you didn't have to go through retailers. You could go straight to the customer. And because of this also, and we talked about this significantly in our reverse logistics section, was reverse logistics. Because of this advent of e-commerce, this emerged as a very key aspect of supply chain management. E-commerce placed a lot more emphasis on product returns, things moving backwards in the supply chain. So this was a huge thing with materials handling, how it changed what we do. In 2003, Walmart, the world's largest retailer, announces RFID requirements. We talked about RFID in our technology section earlier this year. So Walmart started to require their largest suppliers to implement RFID tags on pallets and cartons. Again, not going down to the individual item level, but for larger packaging, pallets and cartons. So this was the first time, again, remember, information is incredibly important. So it was able to keep better accountability of the incoming materials from Walmart suppliers. In 2004, voice-directed picking systems are widely implemented. So what this is, and I've got some pictures of what this looks like, this is the use of a hands-free system. It would be hooked up to your arm as a picker, and you could talk to it. So you didn't even have to look down at it or read it. You would talk to the machine would talk to you. So this increased the accuracy and the speed of picking process in warehouses. And again, this was introduced in 2004. So the Material Handling Industry of America, what this is an industry trade association for companies that provide materials handling and logistics solutions for supply chains. And the Material Handling Industry of America estimates that consumption of material handling and logistics equipment in America currently exceeds $156 billion per year. So companies are buying material handling and equipment systems at an astounding rate of $156 billion per year. And you can imagine that materials handling equipment and systems are often a huge, major capital investment. It's a lot of money for an organization. It is incredibly expensive. So very similar to the decisions that we talked about in our warehouse section in terms of the number, the size, and the location of warehouses, materials handling can affect many aspects of supply chain operations. So just to give you an idea of some material handling equipment that is very common in our supply chains. So lift trucks, racks and shelving, totes, bins, containers, all these different things that we put products in, dock equipment, even packaging, which includes pallets, conveyors, cranes, automated storage, automatic guided vehicles. These all fall under materials handling equipment. And some can be very small, very simple. Some can be very expensive, very complex, very robust. So let's talk about manual versus automated materials management and handling system. So manual materials management and handling systems, they utilize physical force through human labor in order to move products or goods. You are always going to have a person pushing, pulling, lifting, setting down. So this includes pushing, pulling, lifting, retrieving, controlling, carrying, and holding, all done by an actual human being laborer. Though manual, this type of handling there's still equipment that's going to be required. There's manual cranes, there's pallet trucks, there's slings and hook, short distance conveyors and forklifts. So it's not always just done with a person. There is usually some sort of equipment involved, but the main use of movement is via physical force from human labor. So it's actually people doing that pushing, pulling, carrying, holding, setting down. So the advantages of manual systems as opposed to automated systems. So it is cost saving. Manual material handling does not require a heavy initial investments. It's very easy to set up manual systems because you just have the people do the heavy lifting. Then you don't need to buy conveyor belts or big things that are going to be placed in your warehouses. The initial investment is very low and the ROI is very quick to be realized. You don't have to wait a very long time before you start to see things being profitable. And there's the availability of greater space. So manual systems where everything is done by physical force from human laborers does not involve the use of extensive or heavy equipment. So that means we're going to have more room for activities. This increases the amount of usable space in whatever physical facility we have. And it's very easy for employees to adapt. Manual materials handling systems do not involve advanced technology, and thus there's no really intense technology training that is required for the employees. And because the system does not require employees to have any sort of technical expertise, it's easier for them to adapt to the new environment and probably easier for us to hire as well, and hire at a lower rate within our facilities. So of course, there's always going to be trade-offs. There are going to be disadvantages of manual systems. So they are very error prone. So the human intervention makes manual material handling very prone to errors, prone to mistakes, prone to inaccuracies. There could be a lot of errors in inventory management and order fulfillment in manual systems. Another disadvantage is the safety training. Employees need safety training to handle equipment and operations without the risk of injuries or death. We talked about OSHA. That falls on the employer to ensure that their employees are being safe. And this kind of safety training needs to be undertaken very regularly to keep employees up to date with new and updated safety practices. So we've got to be really careful here. Now let's talk about, on the flip side, our automated systems. So automated material handling systems, these are pre-programmed computerized systems with built-in technology to complete the task. And what it does is it minimizes that need for human labor or completely eliminates it. And automated systems typically feature advanced technology for material movement, material storage, access, and location, and do not rely on human labor or human force. So we are just going to have the machines do all the heavy lifting as opposed to having the people do the heavy lifting. So the advantages of automated systems, they're very high cost efficiencies. They end up saving money in the long run. The technology may initially be very expensive, especially if it's a very customized product, but the cost can be compensated because manual labor is reduced. We are not paying actual workers for all that hourly compensation, so we're going to recoup some of those costs. And with automation, tasks can be performed faster with more precision, and this ultimately is going to increase our productivity. Another advantage of automated system, it enhances workplace safety. With automated handling, employees will not have to lift or carry these heavy boxes, heavy products, which reduces the risk of back injuries, of trip and fall accidents. The risk of physical problems like lower back pain, back injuries, and just fatigue are also minimized. It enhances order fulfillment and delivery. So automated handling minimizes errors in that order handling, improves the shipping process, and ultimately quickens delivery. And as a result, our customer service is improved and our customers are happier. Again, there's always going to be a flip side. there are many disadvantages of automated systems. So the capital investment is probably the biggest disadvantage. Automated technology is a very large capital investment. A lot of business owners may be very hesitant to purchase a completely new system or something that is untested or something that is very expensive. And employees need to be trained to operate the system properly. The system itself has to be programmed to function effectively in the specific warehouse space, perhaps to intermingle with the other technology that the company has. And beyond that initial installation and implementation at the beginning of the life, automated systems require maintenance throughout the course of their use. So it's an ongoing source of money that is needed to be put into an automated system. And the lack of adaptability. Automation is most often implemented to replace very simple, very repeatable, very time-consuming tasks in any industry. And changes to inventory or warehouse layout would require completely reprogramming or major construction changes to the systems. So once we input an automated system, we are pretty much locked in. If we want to change it fundamentally, it's probably going to take massive construction, massive reprogramming. So it's not very adaptable if we want to make big changes to it. And not all firms utilize automated systems for material handling. You're probably assuming, oh yeah, everyone uses robots and machinery to do things. A lot of small and medium-sized companies have very effective systems that are nearly entirely manual. They are not automated at all. However, firms of all sizes can implement automated systems. So the combination of customer requirements and an organization's budgets are going to determine whether non-automated, automated, or some combination of both will be employed in their specific material handling. So let's talk more about automated systems. Let's kind of get into the weeds a little bit about automated systems. So the following automated components have become very commonplace in materials handling, and they've really successfully helped achieve improvements in efficiency and productivities in supply chains. So we've got automated storage and retrieval systems, ASRS. We've got carousels. We've got conveyors that could utilize wheels, rollers, or belts. And then we've got automatic guided vehicles, AGVs. And let's talk more about these. So warehouses or facilities that have their entire systems automated are sometimes referred to as dark. And the word dark refers to the complete lack of human input needed in that facility. Robots, machines don't need lights to operate. Humans need lights to operate. We need to see what we are doing. These automated systems don't necessarily need any light to operate. So technically that warehouse could be running completely in the dark. It doesn't necessarily mean all the lights are turned off, but when you refer to a facility that is dark, that's what that means, is that it is very highly automated, so much so that it really doesn't need any sort of human input to keep it running. So that's what that means when we say a dark facility. It's so automated. So ASRS, automated storage and retrieval systems. So what these are computer-controlled systems that put away and pick items in warehouses or distribution centers. And again, this goes with our very high shelving. These can be as high as 100 feet. And there are typically two types. There's unit load ASRS and mini load ASRS. So ASRS systems, they're configured with racks and shelving that are laid out with very narrow aisles in between. And a crane with a really tall mast travels through the aisles and moves vertically and horizontally to the storage picking positions. And when the ASRS system crane reaches the correct location where the item is, the correct storage location, a little carriage travels up that mast to the picking spot, and then it uses some sort of automatic mechanism to reach into the storage locations to either retrieve or return the item. So let's show an example. This is actually from Santa Clara University, their library. So their college library actually utilizes an ASRS system. So let's just take a look at their automated retrieval system here.
As an extension of the library shelf space, the ARS is recognized for being the most monumental computer-controlled location of the library. An automatic request for a book or video can be sent to the ARS with just a few clicks. The ARS stands strong for being one of the most efficient space-saving ways to store and retrieve materials such as books, journals, videos, and other materials that require lots of space. The crane moves to the bin and brings it to the workstation, where library staff locates the item and prepares it to be picked up at the circulation desk. The best part is that requests can be picked up within minutes. To see the ARS in action, visit the viewing room located on the northeast side of the second floor in the Learning Commons.
So this is a great example of an automated retrieval system. So again, the two types of ASRs we have are unit load. So unit load, this is used for handling big stuff. This is used for handling pallets, pallet-sized containers, so big stuff. Now, a mini load, ASRS, is used for handling smaller items, things that weigh less than 1,000 pounds that could be stored in things like, you see I've got a yellow tote, a blue tray, smaller type of stuff. So unit load, ASRS, this is for big stuff, pallet size stuff. And mini load, this is for smaller things, less than 1,000 pounds that can fit in various totes, trays, or even cartons. The benefits of a fixed aisle system such as ASRS are the decreased space required for these types of things. You saw how narrow those the area between the shelving units are. It's incredibly narrow, and it goes floor to ceiling. So you're really decreasing the space required to hold all of the product and materials. And there's reduced labor needed to store and retrieve materials efficiently because we've got the system to do it. And the ASRS systems can also be installed in really harsh environments that could create hazardous conditions for workers that really can't be in that environment for very long, such as like freezers. And because of computer technology involved, ASRS can create a very accurate form of inventory control, and you really only need very few employees on site. Another form of automated system is the carousel. And you see I've got a picture of a carousel. Perhaps when you were younger, you went on these. Now, this is not what a carousel that we talk about in supply chain looks like, but just to give you a little visual demonstration, carousels, these are mechanical devices that house and rotate items for order picking. So it's all about the rotation, going in a circle. The more frequently utilized carousel configurations are the horizontal system and the vertical system. So a horizontal carousel is a linked series of rotating bins of adjustable cells that are driven on the top or bottom by some sort of motor. And the rotation takes place on an axis that is perpendicular to the floor. And usually it goes at about 80 feet per minute. Now, if you've ever been to a dry cleaner and you're picking up something that you had washed and pressed, when they are retrieving, especially in like a very big dry cleaners, when they are retrieving your garment, they will use a horizontal carousel. You can see at the picture in the bottom right, this is an example of a dry cleaner of a horizontal carousel. The picture on the left-hand side, this kind of shows what a horizontal carousel would look like in a warehouse environment, especially for smaller items, where all of these shelvings would rotate. And then we've got our vertical carousel. So essentially it's a horizontal carousel that's kind of turned on its end, and usually it's going to be enclosed in some sort of sheet of metal. And it consists of shelves that rotate up and down inside these metal cabinets. And a lot of times these shelves are going to hold metal trays, plastic bins, and usually small parts. And as the same as with horizontal carousels, an order picture operates one or multiple carousels. Now let's talk about conveyors. So a conveyor system. This is a common piece of material handling equipment that moves materials from one location to another. When you think of a warehouse, perhaps this is what you think of are boxes moving on a conveyor. The majority of businesses that do use conveyors, that's what they move on it. They use it to move boxes and packages, but conveyors are also very useful in applications that involve transportation of heavier, bulky materials. You'll see the picture at the bottom I've got here. It looks like very heavy rock or some sort of material that would be very difficult to transport any other way, but a conveyor is an excellent application to move this type of product. And conveyor systems allow very quick and efficient transportation for a wide variety of materials, which, because they are so quick, they're so efficient, and they can operate on a wide variety of materials, this makes them very popular in materials handling and also packaging industries. They have very popular consumer applications. You are all well aware, I'm sure, if you used a conveyor, especially when you go to a supermarket, when you go to an airport and you're retrieving your baggage. A conveyor constitutes that final leg of item or bag delivery to consumers. And there's a lot of different ways that a conveyor could be constructed. You could have gravity rolling conveyors, which essentially are kind of sloped downward, so they'll use gravity to move. You could have a powered belt conveyor. This is typically what you see in the supermarket. Or you could have powered roller conveyors, where each individual roller is set to be spinning, as opposed to a belt. So there's a lot of different ways that conveyors can be set up. And conveyors are also extensively used with sorting systems. Sorting systems perform sortation of products, goods. Mail is a very common one, luggage, according to the different destinations that the products need to go to within a facility. Sortation is the process of identifying items on a conveyor system and then properly diverting them to specific destinations. And sorters are applied to different applications depending on the product and the speed that we need them to travel at. So it typically consists of a flat belt, a roller, or some sort of a chute conveyor segments that are all put together, and they've got movable arms or pop-up wheels that will pull products into different destinations. And the major benefits of conveyors are they efficiently handle the flow, the automation of processes, order fulfillment accuracy. They're reliable, they're quick, they improve productivity, and they reduce costs. And the disadvantages include the cost of the system. And again, the lack of flexibility once they are installed, and of course, that ongoing repair and maintenance that we need to do on them. So let's watch a video. Let's see if this will work. There we go. Okay, let's watch a quick video.
The rise in e-commerce home deliveries has transformed what fulfillment and distribution centers need from their sortation and conveyor equipment. Not only have throughput requirements increased, but the advent of dimensional pricing means that these systems also need to handle poly bags and bubble mailers, in addition to cartons, cases, totes, and pallets. As the industry leader in conveyor and sortation automation equipment, Honeywell Intelligrated has a variety of accumulation, transportation, diverting, metering, and merging conveyors to meet diverse fulfillment requirements, regardless of product size, shape, and weight. Our high-density, zero-pressure accumulation conveyors rely on patented technology to deliver high throughput rates and superior case, tote, and polybag handling. Through the years, we've received many patents for our innovative sortation and conveyor technologies, such as Soft Touch, Zone Flex, iWatch, and dynamic discharge compensation. With the widest range of sortation equipment options available in the industry, we can help you meet your specific requirements for years of reliable, low-maintenance operation. For warehouses that have no room to grow but up, our flexible vertical conveyor and sortation equipment is ideal for keeping product flowing smoothly and efficiently across multiple elevation levels. To round out our capabilities, we also offer a full line of durable accumulation and transportation pallet conveyor systems for manufacturing, warehousing, and distribution operations.
So that was an ad by Honeywell, and you could really see the sorting that happens in there and how complex these conveyor systems can be. So let's talk about AGVs, automatic guided vehicles. These include material handling equipment that is driverless. You don't actually need someone in them like a forklift. So there's no one operating it, no human operating it, and it moves through a facility over a defined path, typically using some sort of floor guidance system. Something is on the floor that is ensuring that it goes in a proper path. And a vehicle that has a guidance system can travel from point to point without any direct input from an operator. So automated guided vehicles use systems, they'll use electromagnetic, they'll use optical, or maybe even GPS or some other sort of system to track the location of the cart. And most of them have a lot of fail-safe conditions like collision avoidance systems. They're not going to crash at high speeds into each other. They're going to avoid any sort of collisions. And AGVs have programming that determine how the vehicle is going to act, the kind of parameters that it adheres to, perhaps the paths that it takes, or the space that it can be within. And the benefits of AGV system include reduced labor costs, increased safety, increased accuracy, and more productivity. Again, very similar to all of our other automated systems. The disadvantages includes that high initial investments, decreased flexibility in operations, and it's also not suitable for non-repetitive tasks. So if the AGV is going to be doing something different every time, it's probably not best to use an AGV. While currently relatively few firms are currently utilizing AGVs, the market is really expected to grow. It's expected to more than triple to $5 billion by 2026. So this is something that's really catching on in supply chains. Now let's talk about Kiva. So Amazon first entered the automated materials handling space in 2012 when they acquired Kiva Systems for $775 million. And at the time, this was Amazon's second largest acquisition in its entire history. And what Kiva, the company Kiva, they offered automated guided vehicles, AGVs, that could navigate a warehouse using a series of computerized barcodes and stickers on the floor. And a Kiva robot can move independently, and it uses sensors, it uses cameras, so it doesn't actually travel on a fixed path as a typical AGV would. They travel at approximately 1 meter per second and can carry up to 1,300 pounds. And demonstrated the significance of bringing the products to the worker rather than the worker going to the product storage locations during the picking process. So this is typically done at least during the picking process. I've also heard that it's done during the stow or put away process. And again, once Amazon acquired Kiva, they changed the name to Amazon Robotics. And Kiva's automated storage and retrieval systems, before they were bought by Amazon, they were used by other companies. They were used by Gap. They were used by Walgreens. They were used by Staples, Office Depot, Crate and Barrel. However, after these contracts ended up running out with these other companies, Amazon did not renew them. And now Kiva's assets now only work for Amazon warehouses. And they officially changed the name from Kiva Systems LLC to Amazon Robotics in August 2015. And with robots, human workers at Amazon process 3 times faster, and they don't need to actually search for products when picking. So essentially, these robots, when an order comes in to Amazon.com, the robot drives around this like grid of shelves and it kind of shuffles under them because it's very low to the ground, as you see. It locates the correct shelf. It lifts the shelf onto its back, and it will then deliver the shelf to the human worker. And then to avoid any human error, a red laser is going to flash on the item in the particular storage location within that shelf so that the human knows exactly what to pick up. And once the human picker takes that item off the shelf, the robot then returns that shelf back to the grid. And as soon as the robot takes away the shelf, another one arrives, so that human picker is always working. And let's just watch another quick video about Amazon's Kiva.
You've clicked buy and your online purchase is complete, but Betty Bot's work is just beginning. She's a Kiva robot at Quiet Logistics Fulfillment Center. Behind every online store is a warehouse full of merchandise. One is Quiet Logistics, where there are 1.5 million items stored. It's Betty Bot's job to retrieve your purchase, and she can do this faster and more accurately than any human ever could. When you buy something online, your order enters the Kiva database. The software locates the robot closest to your item and directs her to retrieve it. Using a network of barcodes on the floor, she navigates the 300,000 square foot warehouse, tunneling beneath the pods as she moves throughout the grid. When Betty Bot reaches her target, she slides beneath the pod and lifts it off the floor. She carries your purchase through the warehouse street. This area is called the Human Exclusion Zone, where no human may enter. There are 100 Kiva robots operating autonomously on the floor, and the Quiet Logistics crew boasts some of the fastest robots in the business. Tina Botter, Botter Rum, Jukebot, Bot BQ, and Walter Cabot IV. Even in heavy traffic, their sensors keep them from colliding. The server constantly monitors and coordinates the bot's activity. It makes sure the fleet is operating at peak productivity and responds to changing consumer demand throughout the day. It even eliminates bottlenecks at the shipping area, where human workers ready your purchase for shipment to your door. The entire process takes as little as 15 minutes from click to ship. In a given day, the robot crew will fetch up to 30,000 orders, 4 times the volume of standard fulfillment centers, and they're 99.99% accurate. They're also highly efficient, requiring only 5 minutes out of every hour to recharge. The bots are designed to do tasks that humans would be hard-pressed to complete, covering 12 miles of ground per day, operating 24 hours a day, 365 days a year. Forever changing the way our economy moves, from the warehouse to your house.
Okay. Oh. So again, we just watched the video. These are the Kiva robots. So in June 2022, so pretty recently, Amazon has announced an automatic guided robot, an AMR, called the Proteus. And the Proteus is an AMR with a very similar design to that of the Kiva automatic guided vehicle. However, unlike the Kiva, which has to operate in cage-off spaces away from Amazon's human employees, the Kivas cannot be in the same area when they are operating and moving as people. The Proteus, on the other hand, is able to freely work amongst the humans. So humans and Proteus can work together in the same space. So what's the difference between AGVs and AMR? I talked about how Kiva is an automatic guided vehicle, whereas Proteus, Amazon's Proteus, is an automatic guided robot. So the robot, the AMR, can navigate without external guidance. It has freedom of navigation and decision making. And if AMR is transporting any material from one point to another, and say it encounters some sort of obstacle, it encounters a pallet, it will avoid the obstacle and is going to redefine its route. AMRs work better in environments shared with humans due to their ability to make changes and their efficiency in sharing tasks. So AMRs are smarter. They can adapt to obstacles and things that may go wrong, which usually do go wrong, better than automatic guided vehicles. So Amazon is going to use both the Proteus AMR and the Kiva AGVs going forward. Amazon has stated that their legacy systems, Kiva, are more efficient and are often much cheaper, but the Proteus really makes sense in areas where work is being performed where you really can't reasonably physically separate the people from the robots, and there's going to be a much higher variability and more exceptions to what's going on in that area. So Proteus is an additional tool in Amazon's toolbox to choose when they want to add automation somewhere. So they've got two different options now. Amazon also plans on deploying additional automation technology into its warehouses. Cardinal is a robotic work cell that they're working on right now. And you see I've got a picture of the prototype down here, and the Cardinal can pick packages from a pile. It can read the package's label and then places the package in the correct location so it can continue on its journey within the warehouse, within the distribution center. So we will end here for today, and we will continue with part 2 of materials and management and handling here shortly. Thank you so much, and we will talk soon. Bye.